Nice.
Okay, got it. Let's move on. I think we talked about the PXI ecosystem. There's a lot going on, and we have VIP here. I want something very exclusive for our VIP audience that we announce here for the first time in the world.
Yeah, exactly. You know, we're investing a lot in RF, and so we have other RF products coming, and Ramon's always telling us, we got to launch something new at VIP. So I asked the head of our RF product management group to hand carry over our latest RF product. Fortunately, it's a PXI product, so he could actually fit it in his carry-on bag, and bring it here to exclusively announce at VIP. So I'd like to welcome up to the stage Michael Schneider. Mike. All right, Mike, tell everyone what's new.
Hey, thanks, Eric. So, as you mentioned, we're really excited to announce our newest RF product launching here exclusively at VIP 2012. Up here on the stage, I have the new 5632
Hold on.
Vector Network Analyzer.
Explain what a VNA is, Vector Network Analyzer.
I would just assume everyone in here is doing RF measurements by now. But no, you have a good point. So, in a simple way, a Vector Network Analyzer essentially measures the magnitude and phase response of different RF components, such as antennas, power amplifiers, or maybe a filter. And in this way, RF designers can characterize things like return loss, the impedance, and other parameters in their RF designs to a high degree of accuracy. Okay. But I think instead of talking about what a VNA is, why don't we go ahead and demonstrate the new one?
Okay, let's have a look.
So the setup I have here is I have the 2 ports of our Vector Network Analyzer connected up to a 2.6 gigahertz filter that we actually designed for one of our own vector signal analyzers. So if I switch to the demo here, what we see is a common frequency response plot. And what I have a marker here basically indicating what is the 3 dB cutoff of that filter, and we can read up on the screen it's about 2.66 gigahertz. But there's a lot more measurements that can be done with a vector network analyzer, such as we can measure impedance on a Smith chart, indicating the 50 ohm impedance that's ideal on a filter during the passband. We can use time domain analysis to measure discontinuities in the impedance in our setup, including those connectors on each side of the filter and so forth. Now this VNA is filled with a lot more features than I have time to demonstrate here, but let me just name a few. So usually in really high-end VNAs, you have things like the capability of having dual sources with independent source control, deterministic triggering, including off the PXI backplane for things like pulse measurements. And we also have a very innovative fast measurement architecture that's ideal for automated test applications. And Ramon, I think I could go on and on and on.
I have to stop you now.
Believe me, he can go on and on.
Yeah, I know. I have experienced that. So let's fast forward. Let's talk about, in a quick way, all the new products that we are coming out with for PXI, and then we can round that up.
Ja, da möchten wir zumindest noch einen kurzen Überblick geben. Und zwar gibt es ganz neu ein PXI 1085. Das ist ein All-Hybrid-Chassis, 18 Slot. Das heißt, Sie haben die Möglichkeit, in jedem Slot wirklich ein PCI oder ein PXI oder ein PXI Express-Modul unterzubringen. Industrieweit einmalig ist dabei, dass es ein PCI Express Generation 2 Chassis ist. Das heißt, wir haben in jedem Slot eine Bandbreite von insgesamt, wenn man die sieht, 4 GB pro Sekunde pro Steckplatz. Ein weiteres Chassis, das wir kürzlich released haben, bietet mir die Möglichkeit, eine hohe Verfügbarkeit zu erreichen. Ja, das ist ein redundant ausgelegtes Chassis, das bedeutet, ich kann zur Laufzeit eben auch Netzteile auswechseln, beziehungsweise die Lüftungskomponenten, also die Fans, die sich im unteren Bereich befinden. Ja, als Verarbeitungseinheit haben wir gerade schon mal im Einsatz gesehen, neueste Intel-Technologie verbaut in einem PXI-Controller, 8135 mit neuer Core i7-Technologie. Und damit kann ich eben auch sehr, sehr leistungsstarke Embedded-Systeme, Embedded PXI-Systeme entwickeln. 2 Module möchte ich im Folgenden noch vorstellen, die sicherlich von großem Interesse sind. Einmal für den Einsatz, beides häufig im Einsatz im Halbleiterbereich. Das ist einmal ein programmierbares Widerstandsmodul. Das heißt, ich kann hier wirklich auf jedem Kanal in gewissen Schritten verschiedene Widerstandswerte einstellen und damit beispielsweise resistive Lasten oder Potentiometer, RTDs etc. simulieren. Das zweite, da sind wir wieder im Bereich verschiedene Quellen, die es für die PXI-Plattform gibt. Das sind die Source Measure Units, kurz SMUs. Da haben wir auch weitere Module zu dieser Produktfamilie hinzugefügt und ich kann damit einfach noch genaue Ströme letztendlich einprägen, bis in den Bereich von 10 Picoampere.
Okay. I actually wanted to stop you, but you talked about modules and controllers and chassis, and of course we have to uplift the PXI ecosystem if you want to integrate the VST technology. What is this?
Yeah, this one's a little different. So one of the areas where our customers have been using PXI more and more very successfully is in semiconductor tests, both characterization and production test, or ATE. And so this is actually a proof of concept of a system that, in addition to the modules and everything, has a load board interface specifically for production ATE of semiconductor devices.
Wonderful. Okay. I think we'll see much more of that in the next trade shows and so on.
Yeah.
So Eric, Michael, and Christoph, thank you very much. It's the world of software design instrumentation.
Absolutely. Thank you very much, Ramon.
Thank you.
Okay.